In this video we are going to discuss a Leetcode problem of the day. So our problem is minimum number of k consecutive bit flips. It's similar to the problem in the Leetcode bi-weekly contest. Okay, it's similar to the bi-weekly contest. Okay, problem 2. So what we have been given, a binary array nums and an integer k. Okay, we have been given an binary array nums and an integer k. Nums and k as an integer. Okay, so we have to do a k bit flip, that is choosing the subarray of length k from nums and simultaneously changing every 0 in the subarray to 1 and every 1 in the subarray to 0. Okay, basically what we have been given, the nums array. Okay, what we have been given, the nums array. For example, it's given 0 1 1 0 1 and our k is equals to 2. So what we have to do, k means the length, k is the bit flip length of the sub array. For converting its equality means, if k is 2, so we can flip only in the pair of two numbers. Okay, so that's the meaning of the question. We have to return the minimum number of k bit flips required so that there is no 0 in the array. So see here, our first bit flip will be here. So first one is 1 0 1 0 1. Okay, now our second bit flip will be from here. Second bit flip will be here. So it will be 1 1 0 0 1. Now our third bit flip will be here. 1 1 1 1 1. So we can see that we have got our all ones in the nums array. Okay, so minimum number of bit flips are 3. Okay, our output will be 3. Minimum number of bit flips are 3 here. So this is the meaning of the question. So now let's try to understand with the help of another example. Okay, first of all, let's see if we have been given for example an array like this and k equals to 2. So what you can do here, you can do just flip these elements. So what it will be, form 1 0 1. Okay, so this is the in these situations. Okay, in these kinds of situations you have, if I plus k, if our I plus k is greater than the n. Okay, so in such kinds of situations we have to return -1. If our I plus k is greater than n, you have to return -1. Is that clear? So now let's discuss. Our first I will be what in this question? Our I will be what here? Okay, our I is basically what, as you can see here, our I is basically 1. Okay, no, it's the changed one. Okay, this one is basically the changed one. Yes, as you can see here, I is basically what, 2. 2 here, it's index 0 1 2. Okay, I is basically what, 2, and k is also 2. So I plus k is equals to what, 4, which is greater than n 3. Okay, the size of the array is what, 3. Okay, so we will return -1. And yeah, I think you got the this one approach. Okay, now let's try to understand with the help of another means big example. What we have been given: 0 0 0 1 0 1 1 0. Okay, so basically this is our array. Is that clear? And our k is equals to what? K is equals to 3. Okay, so now first of all what we will do, we will check. First we will check the this one. Okay, so our first iteration will be, we give the, first we will check the first three elements. Listen. Okay, so we will listen. First of all, you have to start iterating, means changing the numbers from 0 only. Okay, you can't start with 1, you have to start from 0 only. Okay, so our first operation will be 1 1 1 1 0 1 1 0. Okay, now second operation will be from where we have all four ones, so we will start from here basically, as 0 is there, so from here. So our next array will be what? 1 1 1 1 1 0 0 and 0. Okay, now we will start from another 0. Okay, from here, from the 0, starting 0. Okay, now our next operation is third operation, means 1 1 1, and after changing. Okay, so with respective operations, these are the changed numbers. Okay, these are the changed numbers. uh, these are just our changed numbers. Okay, with respect to the operations. So we have got our answer as 3. Okay, so in this way you have to solve the problem. Now let's discuss the approach. Okay, now let's try to discuss the approach. What approach I have used here? I have used a simple approach, means what I have taken some kinds of for loop and if else, like this kinds of approaches, a simple one. Now let's try to discuss. First of all, what we will do, let's try to understand it with the help of the code. Okay, okay, so now first we will import, we will solve it with the help of a list. Okay, we will understand slowly by typing the code. From typing import list, we are now importing the list here. Okay, now what we are doing, n equals to the length of nums, is the length of an array. Okay, basically now we are initializing our flips to 0. This is basically what our flip count. Okay, now we are initializing our flip count from past for I to 0. Okay, it keeps a track of current flip state, means number of flips performed up to current index. Let's write it. Yes, Okay, we are initializing it to 0. This is basically what? This is basically our current flip state. Current flip state. Okay, it gives the track of current flip state, means number of flips performed up to current index, that is number of flips performed up to current index, up to current index. Okay, now first of all we will iterate through a for loop. We'll iterate through a for loop for I in range n. First of all we are iterating through the for loop. Now let's check the original conditions. Okay, now let's try to understand the original conditions. So first of all, what we will do, we will check if our I is greater than or equals to what? K. If our I is greater than or equals to K, means what is the meaning of means checking? What is the need of checking? If the current index I is greater than or equal to K, we are checking if a flip is started at I minus K has expired, means effect ends at index I. Okay, so basically we are checking this, and first of all we are checking this, and what, and we are checking is flip. First of all, uh, we are initializing, wait a minute, we will check here. Okay, is I is greater than or equals to K. If it is so, we will decrement the flip count from past for I. Okay, here now let's try to understand one simple thing. Okay, we are taking the initializing a list here. Okay, a list name is flip to false. Okay, we are initializing it to false. To what? Till n. Is that clear? We are initializing the list to false from n. Okay, it gives a track of the start of, sorry, it gives a track the start of the flips. Okay, yes. So now basically what the is flip falls into n means, is flipped falls into n means, what does it means? Okay, it means if our n, for example you have been given an array 0 1 0, what is our n here? N equals to what? 3. Okay, so it means for n equals to 3 is, wait a minute, it means our falls into 3. Okay, so basically it will be what? 3 times false, false, false. Okay, so this is the initialization. Okay, now we are checking what? We are checking is flipped I minus k. Okay, we are checking is flipped for I minus k. So means what does it means? Basically it means that its effect ends at the index I. Means if a flip is started at I minus k has expired. Okay, so we are checking it. We are checking is flipped I minus k. Okay, so basically it checks if a flip is started at I minus k has expired. Okay, means the flip has ended or not. Means for example 0 1 0 1 1 0 1. So if you flip here, first you are flipping here. Okay, so it will be what? New will be 1 0 0 0 1. So our new flip will be where? Our new flip will be from here. Okay, so this is the use of is flipped. Okay, it's check if it is expired or not. Okay, now let's initialize it in the code. If our I is greater than equals to k and is flipped of I minus k, so our flipped count from past for I is decrement. It is decremented here. Okay, so we are check for expired flips. Looking for expired flips. Okay, yes. Now what we will do, we will check if the current bit needs to be flipped, which is determined by what? It is determined by flipped count from past for I modulo 2. If it is equals to nums of I, means if they are equal, it needs to be flipped. We are checking. Let's make it flip count only. It's too hard for you to understand, I think. Flip count. Okay, it will be easy for you to understand. Hmm. So basically our flip counts. Okay, if our flip count modulo 2 is equal to nums of I, Okay, if our flip count modulo 2 is equal to nums of I, means our current bit needs to be flipped. Okay, so this is basically the thing I am asking you, means asking to explain. Now let's initialize it to the code. If flip count modulo 2 equal to 0. Okay, if it is equal to sorry, nums of I. Okay, so what we will do, we will do the checking of I plus k greater than n. Okay, we will check if our I plus k is greater than n. Now we will check here if our I plus k is greater than n. If it is so, we will return -1 as I have discussed earlier. Okay, so now what we will do, we will increment our flips. We are incrementing our flips. Okay, and also our flip count. Now what we are, our is flipped of I is initialized to true. Okay, we are initializing the flip I to true. Okay, so basically what I am able to say, means what I am trying to say here, while incrementing the flip state, we are incrementing the flip state here. Okay, now in this we are incrementing the flip count, increment the flip count. Okay, now here mark the start of flip, mark the start of a flip. So basically what we are uh, checking the start of the flip. Okay, means if it is 0 or not. Now we are just returning the number of flips, return the flips is flipped. Now let's try to run the code. Yeah, it's not giving the expected answer. So now let's try to debug the code. Okay, what I have missed here, flips equals to 0, flip count equals to 0. Okay, it's flipped. Image is flipped. We are returning -1 here. So basically what is happening here, now let's try to run it one time. Yeah, now also it's not giving the expected answer. What is missing here? I'm also not understanding. From typing we have imported list. So basically what I have done the error here, as you can see, it must be indented to the correct position. Okay, so this was the error which was coming in between. Yeah, now it's giving correct output. Yeah, our code is being accepted here. So now, okay, so now let's try to understand it for each iteration. Let's try to understand the code for each iteration. Okay, so it will be more easier for you to understand. Let's take a simple example of yes, let's take our nums array as 0 0 0 1 0 1 1 0, and our k is basically what, 3. Okay, now our length of the array is what, 8. Our flips equals to 0. Okay, now our flip count is also equals to 0. Yes, now our flip count is also equal to 0. We initialize it to 0. Okay, now our is flipped. Our is flipped, we will initialize 8 false in it. Okay, so this is our list here, and we have initialized 8 false in it. Okay, so now first our first iteration. Our iteration number 1. Okay, so for I equals to 0, so for I equals to 0. Okay, now we will check here if our nums of 0 is equals to flips of, as our I is smaller than k, as our I here is smaller than k, means 0 is smaller than k. 0 is smaller than k, so no expired flips to remove. Okay, so now we will check if our